So this video is on lessons 3 and 4, and lesson 3 talks all about the factored form of a polynomial. So factored form means just that. It should be factored, which means to factor, you are breaking up the polynomial into products of its factors, and each factor should not have a variable that has an exponent higher than 1. If it does, that means it can be factored further. So factored form, it is written as the products. It could only be one product, but it's usually more than one. So products of the factors where the greatest exponent of the variable, it's usually x, but it doesn't have to be, is 1. So if you have an x squared that's left, that means you're not done. You can factor it further. If you have x cubed, that means you're not done. You can factor it further. So this is the factored form, the general form of any polynomial. Now think back to when we did quadratics. You guys know how to factor this. We did, for this particular one, first we checked for a GCF, which there isn't one. Then we did split the middle, but remember you multiply the 3 to the negative 10, so that's negative 30. And then you picked a pair of factors that multiply to negative 30 but add to 13. So that's going to be 10 and 3. And you want positive 13. Actually, no, that doesn't work. If you do 10 and 3, you can get 13 if you add them together, but you want a negative 30 when you multiply. So there is another pair. It's 15 and 2. So if you have negative or positive 15 and negative 2, that would give you positive 13. So we rewrote this as 3x squared plus 15x minus 2x minus 10, and then we factored by grouping. So we grouped the last two and the first two, pulled out GCFs, so we can pull out a 3x, so that's x plus 5. We want x plus 5 in the second grouping, so we're going to pull out a negative 2. That gives us x plus 5. So this factors to be x plus 5 times 3x minus 2. This is the factored form of that polynomial. Notice there's multiplication between my two factors, and my highest exponent is a 1. We don't ever write x to the first, but that's the highest. So working backwards, well, first of all, you need your factored form to look like this. Now, a is just some number. Sometimes a can be 1, so it's going to look like there's nothing out in front, even though there is that imaginary 1. So like in this case, our a would have been 1. We just usually don't write it. But it's not always 1. There could be a 2, a 3, or so forth. So in order to write your equation in factored form, they have to tell you where the roots are. So they told us for this first one, here are the 2 roots. Okay, and they want us to write the equation, and they tell us it has to go through this point. This point is, we are going to use it to get a. Okay, we can get our factors by just knowing our roots, but we won't know if there's a number out in front unless we plug in this point for our x and our y and solve for a. Again, if a turns out to be 1, then technically you don't need to write anything out in front. So working backwards, here's what I know. I'm going to work backwards from factoring. Remember when we would t-chart and we would get, after we factored, we would t-chart and we would get our 2 x's. Well, now I'm going to work backwards. I'm going to move the numbers to be over with the x to get my 2 factors. So I'm going to add the 3 over to that side. So my 1 factor is x plus 3. Then I'm going to subtract the 4 over to be with the x, so my other factor is x minus 4. Now I need to figure out, and it's always y equals, if there is a number other than 1 that goes out in front. To do that, I'm going to plug in this point for x and y, and then solve for a. So here's what I have. You ready? I have that y is negative 50. I don't know what a is, so I leave it a. I know my x is 2. So I have 2 plus 3 and 2 minus 4. So all I did was take what I had so far in my factored form and plug in x and y and try to solve for a. So now I have 2 plus 3 is 5. 2 minus 4 is negative 2. I'm going to multiply all of this together. That's negative 10a. And then I'm going to get a alone. So I'm going to divide the negative 10 over. So negative 50 divided by negative 10, a is 5. So now I'm going to go back over here and put a 5 out in front. And this is your final answer. So it was some number other than 1. So you got to make sure you put what it is out in front. All right, the next example, it says create the equation of a cubic. Cubic is 3. That means I'm going to have 3 roots or 3 zeros. But you'll only notice they gave me 2 zeros. But then they said this, it has a double 0 at negative 2. So what that means, if I rewrite all of this out, we usually don't write the double negatives twice, or the double roots, sorry, not double negatives, double roots twice, because it's the same root. But in order to get the equation, I do have to write it twice, because technically there were 2 of them. We just usually don't write 2 of the same answers. So now I'm going to get these numbers onto the same side as x to get my factors. So I'm going to add 2, so I get x plus 2 as my one factor. I'm going to add 2 again, so x plus 2 is my other factor. And then I'm going to subtract 4 over, so x minus 4 is my other factor. So my equation is going to look something like this. I now just have to figure out what a is, if there is an a. So they told me, they secretly told me a point. They said the y-intercept is 16. Well, the y-intercept always has an x-coordinate of 0. So that means they told me this point, 0, 16. So now if I plug those in for x and y, I get 16 equals a times 0 plus 2, which is 2, times 0 plus 2, which is 2, times 0 minus 4, which is negative 4. Multiply all of that together, so you get 4 times negative 4, that's negative 16 times a. Divide the negative 16 over. You actually turn out to get a as negative 1. So now I have to go over here and put negative 1 on front. So you do need to ultimately find your a. It could, if it turns out to be 1, then technically you don't have to write it because 1 times anything keeps it the same. But odds are it's not going to be 1. So make sure you try and check to find a. Okay, so the next lesson is all about what polynomials are, how to identify them, and then how to work with special identities. So if you follow along with reading what the definition of a polynomial is, a polynomial is an expression that consists of addition or subtraction between the variables. And you can have any variables, most likely they're x and y, but they could be any variable, any letter. And coefficients. Coefficients, remember, if you forgot what coefficients are, they are the numbers in front of the variables. I'll write out variables. And then they have to be raised. Here's the kicker, ready? They have to be raised to non-negative integer powers. Now, non-negative means 0 or positive. So 0 or positive integers, which means they have to be like numbers on a number line. So you can't have decimals or fractions. Okay, so here's an example of what a polynomial looks like. You've seen many polynomials in your life. You may not just have ever realized that that's what they were called, or you may have. So you could have like 2x to the 4th minus 3x squared plus 10. I don't know. So you got variables separated by addition and subtraction. The exponents are positive and they are integers. Here's a non-example. Y equals 1/2 x to the negative 2nd minus 3x to the 1/3 power. So there's actually 2 things here that make this not a polynomial, and it's actually both exponents. This one is negative, and this one is not an integer. So both of those make it not a polynomial. Granted, you really only need one of them, one thing to make it not a polynomial, but in this case, just to show you, let me add on one more thing. Let's add on a 7x. So that actually would qualify as part of a polynomial. The 7x would be fine, but the rest of it, since you can't have negative or fractional exponents, it's not a polynomial. Now, the other part of this lesson talks about identities. Identities are equations that are true for any number that you plug in. So they are always true for any number that is substituted in for those variables. So all of these identities you have to know. Some of them you've seen before, and some of them just make sense. But you have to know them so that you can use them to help you with some calculations, and you may be asked to prove that they work. Somebody long ago actually had to prove it, so they might ask you to prove it as well. So the first one is that when you take any two numbers, square them, and subtract them, you can break it down to be x minus y times x plus y. This is the factoring of two perfect squares. You've done this a million times. You've been asked to factor like x squared minus 9, and it factored to x minus 3 and x plus 3. The next one you've also done a million times. When you square out a quantity, remember that it's really two of them, and if you square that out, you will get something like this. Granted, they will be numbers and not letters. This one is the Pythagorean theorem. You better recognize that. And then the last one you probably haven't seen yet, but it's when you cube a quantity. So cube means three of them. So you're going to have 3a plus b's. And you could sit here, yes, and multiply them all out. So you would start by multiplying the first two together. You'd end up getting this, and then you would multiply that by the last a plus b. But it's kind of easier if you just kind of know this, because then you don't have to sit there and double distribute two or three times. So we're going to actually do some examples. So the first one, we are going to use this first identity to evaluate 50 squared minus 49 squared without using a calculator. So if I use this first identity in the first example, okay, I'll do equals over here. My x is 50, so this factors to be 50. My y is 49, so it's 50 minus 49, and then 50 plus 49. Well, you can do those in your head pretty quickly. 50 minus 49 is 1. Times 50 plus 49 is 99. 1 times 99 is 99. So you just did 50 squared minus 49 squared without a calculator. The next one, we are also going to use this same identity to help us evaluate 51 times 49 without using a calculator. So 51 can be rewritten as 50 plus 1, and 49 can be rewritten as 50 minus 1. Well, we know what 50 plus 1 is. That is 51 minus 1 squared, 51 squared, sorry. Because we're plugging it into here, so we're going backwards. So you actually started on this side and went back to this side. So that is, so 51, or 50, why did I write 51? This should be 50 squared minus 1 squared, because 50 is your x and 1 is your y. 50 is your x and 1 is your y. So that went in for x and y. So 50 squared, you actually should be able to do that in your head, because 5 times 5 is 25, and then add 2 zeros. So it's 2,500. 1 squared is 1. So 2,500 minus 1 is 2,499. So this was using the same identity, but we went backwards. We rewrote 51 and 49 using 50 and 1, and then we figured out what our x and our y were and plugged it into this side. The next one, we're going to evaluate 35 squared by using this identity here. So we are going to rewrite 35 into two numbers. We're going to break it down into two numbers that we can do in our heads. So I am going to break 35. You could break it down into other numbers if you know them in your head, but squaring, I'm going to break it down to numbers that are a little easier to work with. So we're going to do 30 plus 5. 35 is also known as 30 plus 5, and then I'm going to square it. Well, if I use this identity, it says take your first number, which is the a in this case, and you're going to square it. So that's 30. So you're going to do 30 squared plus 2 times your a, which is 30, times your b, which was 5, and then plus b squared, which is 5. So 5 squared. You should be able to do all this in your head. 30 squared is the same as just 3 squared, but with 2 zeros. So that's 900. 2 times 5 is 10, times 30 is 300, and then 5 squared is 25. Add all of those up in your head. It's 1225. The last one, 11 cubed, we are also going to do without a calculator, and we're going to use this identity. So the only one we did not use was the Pythagorean theorem identity. So 11 cubed, we're going to break that up to be 10 plus 1. And then we're going to cube it, and we're going to use this identity. So this identity says when you have two things added together and you're cubing it, you take the first thing and cube it. So that's 10 for us. So we're going to do 10 cubed. Then it says to add on 3 times whatever the first number was, which was 10 for us squared, times the second number, which was 1, plus 3 times the first number, which was 10, times the second number squared, which was 1, and then plus the second number cubed. So for us, that was 1 cubed. So all I did was plug in this for A, 10 for A, and 1 for B. This was your A and your B into that identity. Now you can evaluate that in your head. So 10 cubed is 1,000, 3 zeros, plus 10 squared is 100, times 1 is 100, times 3 is 300. 1 squared is 1, times 10 times 3 is 30, and then 1 cubed is 1. And now add all of that up, you get 1,331. So this was practice with just using these identities to help us evaluate problems a little quicker and easier without a calculator. So that was it for lessons 3 and 4.